I always maintain heating my water year-round. These are one of the most inefficient pieces of equipment you have in your house, electric water heaters. So I basically heat this water year-round, burn coal year-round. Electric is my backup heat. It's not a heat that I prefer to use. It costs a lot more money, but like this is just a regular old standard hot water heater, electric water heater. I bought it in 2009. I got it wired up, but I have the breaker turned off. I did install another thermostat which operates and controls my circ pump that circulates this water heater water, my domestic water, to a heat exchanger that's inside my boiler. And this circulator pump for my domestic water, the size that I went with is a 007 stainless steel, rated for domestic water. You got to lay these pumps. There's only a certain way you put these pumps. You can't put it vertical or whatnot. This motor has got to be horizontal. But the way I install most everything I install, I've got valves. So if I needed to change this out, I can valve this pump out and change my pump. Do what I need to do. I can change the cartridge, or I can change the whole pump out. It's actually running right now, and I'm putting about 135 degree water in there because my wife's actually washing the dishes, and it will shut off when I reach 140 with this water heater, because I've got a mixing valve, so I know I'm not sending her 140. I'm only sending her about 115 degree water. So I don't really never run out of hot water at all. But yeah, I use a Taco 007 SF5. They've got so many different pumps out there. You just got to know how big's your loop, what's your head pressure, or what's your head, how many gallons a minute you want to move. My boiler is not that far on the other side of this wall. We're in the basement right now. My ground level is probably about right through here is my ground level. So my boiler ain't it's not that far from here. So I don't have a lot of head. And okay, so say for instance we're putting about 135 degree water into here. My boiler temperature water coming over here is 157. Boiler should be running right now, because we're putting a big demand on it so far this morning. But I've got 150 degree water coming back. So basically that boiler water and my domestic water and that coil that's inside that boiler is pretty close. About 153, 157. I don't have a lot of heat loss. That's my main way of heating my water, but I do have another heat exchanger I put in as an afterthought, simply because I've got cold water coming in and the dip tube is down low. Once this circ pump kicks on, it's pumping water out of the water heater to the boiler and back through a heat exchanger in the boiler, and it comes back fairly hot, but I was clashing my temperatures in my water. So I says, well, why don't I just preheat all of my cold water so I won't have such a big delta T down here at the bottom of the water heater. All it is a stainless steel piece of pipe, some flat plate, stainless steel flat plate. I put a coil in there. That coil consists of 20 feet of 1/2 inch stainless tubing that I coiled up in there. It wasn't a tight coil, it was like a spring coil. And my domestic water goes through that coil. It'll just come straight down. It comes through here and it goes down the coil, and then it just starts working its way up, getting heated up with the boiler water that comes into the bottom. The heat rises, so we come into the top and then we go out back to the boiler. But my domestic water goes through that coil and comes back out, and then it comes out these lines and straight into my water heater. I don't see, there's a little differences in pressure in my hot water fully on versus my cold, but not much to tell. There's plenty of hot water to go around. I don't lose pressure. I do have a pressure pump, a Gruns Force pressure pump here that boosts me up, and I maintain about 76 to 80 psi. But it's all stainless steel. Well, it's copper that goes into stainless steel. I got unions here that if I need to deal with any scaling or anything that binds up in here, collects or whatnot, or I need to flush it out, I just valve this system out, and instead of my return coming through here and then out, my return will just come this way and then out, and I just valve it out there, and right now I just bypass this whole heat exchanger, and I can undo these unions, drain the system. I can bypass my cold water here, so my cold water will go straight into the boiler or straight into my water heater without going through this. If I ever had to take this out, repair it, got a leak on these hose or whatever. I try to do as much as I can with valves, so I can replace parts and pieces and work on things without having to really interrupt the whole system. Along with this water heater, anytime you're heating water, it expands. And with that expansion, these water heaters, if this valve does not work properly, temperature and pressure valve here, then you can, and I've got this hose in there because I use my mop bucket so I can tell I don't want my floor to get wet. I haven't had a problem with it, but basically, if this valve fails, this thing can build up so much pressure because city water, most municipalities, has got a check valve, or it's got a backflow preventer of some sort. Once it leaves the city main, comes your way, it doesn't get back. So like the old systems, it equalizes the pressure that way, but nowadays you've got a backflow preventer, so all of your water, once you're heating it up, it expands. And when you're expanding, I mean, it'll expand your hot water side, it'll expand your cold water side. So highly recommended to put an expansion tank, depending on your size of your system, depends on your size of the expansion tank, but put an expansion tank in here. Basically, I got cold water in here, about this much, and then I've got a diaphragm in here, and I've got air, and I match that air pressure with what my max pressure would be, and that's about 80 psi, 76 to 80 psi. I think it's about 76, and that's what that's how much air I put in there pressure wise, and then therefore it maintains. And if I end up building too much pressure in here, it just pushes down on that air. Air is a lot easier to compress than water, so I don't have an overpressured system. When you could tell if these tanks fail, it's hollow and solid here, and it's more hollowed down here, so you can tell. And also too, this tank's got a little clear indicator on the bottom, and you can see it, and if you lift it up, you can kind of somewhat see if that thing failed, then that will change colors and will tell you that you've got water where you're not supposed to. The noise you're hearing is my pressure pump, so I guess my wife's doing dishes, so she's utilizing water, so we're maintaining that much pressure. If we're on city water, she was running it, I'd probably be at 30 psi in here, and it's just not enough water to, we want water pressure. But yeah, these things can be really dangerous when you're putting a lot of pressure to it, or you're heating water and pressure pump, and you don't want to go over pressure. You can make a bomb out of these things. There's a lot of YouTube videos out there on these things becoming bombs. Because I put such hot water in here, and we haven't had electricity hooked up to this water heater for quite a while, years, other than emergencies only. But as what happens is, this is called a tank booster. Here's the paperwork on it. It says get more hot water. So as what I do here is, my water temperature is about 130 degrees in this tank, but I go through this mixing valve, and I will inject cold water and I've got it set for about 115, 120 degrees is what I like to have going out to the house. I threw out all the faucets and whatever. And yeah, I got babies, so I don't want to scald my babies, but I don't want to run out of hot water either. So if you don't run out of hot water, this is 50 gallons and it maintains hot water. I can take as long a shower as I want, depending on how big a water bill I want to have. But so yeah, I've got preheat my cold water. If I need a booster, then I'll turn that pump on, be it through a thermostat. It'll help maintain the heat, and then I bring that temperature back down before I go out to my faucets. So that's my domestic water heating system. So yeah, standard old water heater. I've looked at external tanks and doing all this other stuff, and they do have tanks with heat exchangers built in them and stuff, but I really didn't think I needed to spend the money on that because I always wanted that backup. If you got any questions, yeah, leave a comment. I'm not a plumber, I'm actually an electrician, so this is all the stuff that I've kind of watched on YouTube and kind of picked up and whatnot. But you see something that you got questions on or whatever, please leave a comment. That's all I can say and testify is that it works for me. It's working how I thought it would once I put it together. So if you have a comment or see something out of whack, leave a comment and let me know. I appreciate it.